Our second problem is, by using the Euclid division lemma, we have to show that any positive odd integer is in the form of 6q plus 1 or 6q plus 3 or 6q plus 5, where this q is the sum of the integers. So here that first a small definition we'll get to know. This even, here we got an odd. What is odd and what is even? Even number when any number is divided by even number, any number divided by 2, if it leaves remainder as 0, then that number is called even number. So remaining all the numbers are called as odd numbers. The numbers which won't leave a remainder 0, those numbers are called odd numbers. So just to know this, you have to keep in mind. Now I'll go into the problem. So we have already Euclid's division lemma algorithm. According to that one, any number that may be a, that is equals to bq plus r. So here we have to remember that so 0 is less than or equals to the r, and r is less than b. So in the problem we have got a 6q plus 1, 6q plus 3 and 6q plus 5. So these are the odd integers we have to prove. These are odd or even. So, and if we are comparing a given number, let's take that a is equals to 6q plus 1, where we have already that r is, and here the value of b is 6. So we can take the values of r. So 0 less than or equal, so we will get the 0, 1, 2, 3, 4, 5. In the place of the r, here by substituting a 0, 1, 2, 3, 4, 5. So if we are getting the remainder other than the 0, we can say those are the odd integers. So now what we do is we have to start with the 0. These two we are comparing. So now if r is equals to 0, a is equals to 6q plus in the place of r we have to take the 0. Now so q may be any of some integers we can take. So any integer if you are taking as a q, 6 into, I'll take one integer 2 and plus 0, 6 to the 12, 12 plus 0 is 12. So as we know that any number divided by 2 and leaves remainder 0, that is even number. Let's check that so 12 is divisible by 2 or not. So 2, 6, 12, the remainder is 0. So in this case we can say that so 6q plus 0 is even. 6q plus it is a even number. And coming to the second one, if r is equals to 1, a is equals to 6q plus 1. So as it is, we can take a 2, 6 2 plus 1 from here. 6 2 is 12 plus 1 13. Let's check that. 2 13, 2 6 are 2 and remainder is 1. so it is not leaving the remainder 1, it is odd. Next, if r is equals to 2, we will check a is equals to 6q in the place of r 2. So 6 into 2 plus 2. We are taking always q as a 2. You can take any number if you want. So 6 to the 12, 12 plus 2, 14. So if we will check with the 2, 7 the 14, remainder is 0. It is a even number. So if we take r is equals to 3, a is equals to 6q, in the place of r we will substitute the 3. So in the place of q, again we will take a 2 plus 3, 6 to the 12, 12 plus 3 is 15. If you are dividing with the 2, so 7 the 14, remainder is 1. It is odd. So we have completed 0, 1, 2, 3. Now we'll check with the 4 and 5 also. If r is equals to 4, a is equals to 6q plus 4, and in the place of q I am substituting 2 again, plus 4, 6 to the 12, 12 plus 4, 16, 16, 2 8 is 16, it is even. And the last number is if r is equals to 5, a is equals to 6q plus 5, 6 into 2 plus 5, 6 to the 12, 12 plus 5, 17, 2, 17, remainder is 1. It is odd. So as we have completed all the numbers 0 to 5, we will stop doing a problem here. But we got to know that 6q plus 2, 6q plus 4, we have got the even numbers. So the remaining all the numbers 6q plus 1 and 6q plus 3, 6q plus 5 are odd. As we can also get to know that it is a one of the pattern. Okay, 6q plus 1, 6q plus 3, 6q plus 5, 1, 3, 5 are odd numbers. So consecutive to this, we can also say that 6q plus 7, 6q plus 9, 6q plus 11, 6q plus 13, and so on are also odd numbers under Euclid division lemma algorithm.